Hi, so this video is on upstream downstream problems in the applications quiz. It's a word problem, so let's take a look. A boat travels upstream for 3 hours before turning around and coming back. If the return trip takes 2 hours and the current is 5 miles an hour, what is the speed of the boat in still water? Okay, so I like to approach every word problem thinking that x is what we're solving for. So it says, what is the speed of the boat in still water? I'm going to call that x. And I like to write that down. So let's write that down. This is something we'll need in a second. So x is the speed of the boat in still water. So next, let's see what else, what other information we have here. Pull this back up. So we know that the distance the boat goes is the same. So that's one thing to know. That although the boat traveled at different speeds up and down because there's a current in one direction, the boat actually went the same distance up and the same distance back. So that's one thing to know. So what exactly, how do we find the distance? As I wrote down here, rate times time equals distance. So if you think about that, if you're going 60 miles an hour in a car for 1 hour, you've gone 60 miles. And what we did, we just said 60 miles per hour times 1 hour. That equals a distance that equals 60 miles. So we see that rate times time equals distance, and we're going to use the same thing. Okay, so we know x is the speed of the boat in still water. And what else do we know? Let's see. So a boat travels upstream for 3 hours before turning around. So the speed of the boat is the speed of the boat in still water, and going upstream, it's going against the current. So we're going to subtract 5 from that speed. So for it's going for 3 hours at x minus 5. So let's make a little table here. So I got this table. So trip up, we said we're going against the current. So if x is the speed of the boat in still water, you're going to get x minus 5 miles an hour. Times time, we said that's right in the problem. 3 hours, that give that to us. And then distance is the product of those. Just like we said 60 miles an hour for 1 hour, you get 60 miles. You get the product of this. So distance is 3 times x minus 5. Oops, sorry, I was holding down the shift key there when I typed that. Again, I messed that up. I am so sorry. X, let's see if I can do this right. X minus 5. Got it. There we go. Okay, it's the product of these two. And then the trip down. Well, they said it takes 2 hours and the current is 5 miles an hour, so you get an extra 5 miles, x plus 5 there. And then the time, we said 2 hours. And then again, the distance is the product of those two times, see if I can do it this time, x plus 5. Thanks for bearing with me. And what we said is if the boat travels the same distance up and the same distance down, just the speeds are different, the distance it goes, even though it took different amounts of time, should be the same. So we'll be able to write one equation using these two. Let's go ahead and copy these and see if they'll paste in our Word document here. So we just have that. Okay. So we know one's the speed up, one's the speed down, but x will be the speed of the boat in still water. So all we have to do is say these are equal because these are distance, right? Those are distance. So those two things should be equal. So let's pull up a little equation editor here, and we can write 3 times x minus 5. Well, that's equal to 2 times x plus 5, right? These are distances and they should be the same. So if we go ahead and solve for that, we distribute the 3 and distribute the 2, we get 3x minus 15 equals 2x plus 10, right? Distribute that 2 and the 5. And then let's solve. So if we add 15 to both sides, we'd get 3x equals 2x plus 25. And if we subtract the 2x from the 3x, then we get x equals 25. So x is the speed of the boat in still water, and it should be 25 miles an hour. And let's just click on the button here and see if that's right. 25. And that is your answer.